Good morning. Had to check, it's pretty close. Good morning, ladies and gentlemen of Precalculus. We're going to pick up where we left off. And didn't we just finish with problem 49 yesterday, kind of quickly at the end of class?
Yeah, we did.
Is that how it worked out? But the process, I just leave it here at the beginning to remember the process, that you find which trigonometric ratio is related to, in this case, the opposite is 15, the hypotenuse is x, and so opposite over hypotenuse equals the sine, and then you can solve the equation, and then when you press that calculator button, if your calculator is in degrees, you would get this 26.824. Does that make sense?
Yeah, I mean, wasn't Elizabeth confused about it though?
Yeah, I think she was a little bit. I think she was. Let's go ahead and look at, I want you to go ahead and work out number 50, and I'll choose somebody. And I had,
Can I borrow a calculator?
yes, we had,
I have two that I don't understand.
this one?
It doesn't do this function.
Oh, it doesn't have the,
I don't understand. So it makes it harder.
okay, yeah.
I don't understand.
Which ones?
52 and 54.
52, 54, okay, we'll get to those.
I have the rest of them, I understand.
Oh, did you do all the rest of them?
I just have to click what it's about.
Okay, beautiful. Good, good work, keep going good. So 50, anybody else have trouble with 52 and 54? Justin, you have trouble with 52 or 54? No, you have trouble with all? Okay. But can you do this one, Justin? I want you to do this because I may call your name in a minute here. Which trigonometric ratio is this one going to be?
It's going to be cosine.
Cosine, okay? Good. Good work.
Oh, I was on the wrong one. Never mind.
You're on the wrong one?
So you do,
Okay. All right. What happened is we're going to call somebody, but due to popular demand, I got put on the name wheel. We had a student drop the class yesterday, and I got nominated to take her place in the draw. So now I'm part of the mix. We'll see how that goes. Okay, it's going to be, is it Riley or Robert? It's going to be Riley. Now Riley, I'm sure Riley's up to it. Riley always comes to play. Oh wait, Riley.
so it's going to be cosine of 39 equals 23 over x. And then to change it, I did x equals 23 over cosine of 39.
So did you do this kind of in a double step in your mind like that? Is that how you did it?
Yes.
Yeah, so what she did for viewers, she cross multiplied the x and then cross divided the cosine 39 degrees. Is that about right? So that's a nifty little algebra move she threw down on us, right? Good job on throwing down the nifty algebra move on us, Riley. Good job. All right. Then what'd you get for that, I guess?
29.596.
And let's go ahead and make sure that that answer makes sense. So would 29.596 make sense, just kind of looking at the drawing? Yeah, it could, right?
Yeah.
And she checked her calculator, make sure her calculator was in.
When you, I got a calculator, it has to be in writing or?
Okay, I was just about to say, okay, let me complete my thought, because Justin, you asked the question right when I was about to ask the related question. So what Riley did first, when she worked this out, is she checked her calculator to make sure her calculator was in degrees. So what it is, Justin, you asked that question in mid-sentence when I was already, no, what it was, it shows that you were thinking of the same thing I was. So your question was as relevant as it could possibly be. So I give you credit for that. In fact, so much so.
You get a sticker.
Yeah, so much so, Justin. I'm really happy about Justin here. All right. Very good, very good. Let's get this. Okay, next. Okay, I'll shuffle once. Elizabeth, I got put on the name wheel.
No, oh God.
I got nominated, Elizabeth, to take Chloe's place on the name wheel, so that's what's happened on this. All right, Justin.
Could you just like set it up for me, let me get it started?
Okay, let's talk about this a little bit then. So let's talk about which sides they are. Here's your angle here, right? So this side over here, Justin, is what? That's your opposite side, right? And this side over here is what?
That's the
Adjacent. So what you're looking for is the ratio that involves adjacent and opposite.
what was it?
So you have, which trigonometric ratio involves adjacent and opposite? Tangent, right? So what you'll do is you'll put tangent of this angle, 57 degrees, equals your opposite over your adjacent. And then you can do some quick algebra jujitsu like Riley and solve for y. Is that what Riley was doing? Some algebra jujitsu?
Y equals 32 over.
So what you're saying, y equals 32 over
Tangent.
tangent 57 degrees? No, I think we I like the ring of it, the Riley Jiu-Jitsu method. I like that, I think that because it has like a title now.
I'm hoping I don't get weeds. I'm just gonna have to do it.
So you had a question about 52 and 54?
Yes.
Still? Okay, here's what I'll do. If it happens to be you, who else is having trouble with 52? You are? You are a little bit too? Are you okay with 52, 54? What about you, Robert? Can you do 52?
I don't know, just under,
Elizabeth, can you do 52?
I'm just ready.
You're working it now? Okay, I'll give you another minute, then I'll call on somebody. And whatever it is, I'll work with whoever it is. If you're just flummoxed by it, I'm gonna go look at it, what it is, because I don't remember what it is
I
right
had
now.
like it broke out,
Okay,
but I don't know what we're supposed to do on it.
Okay. Okay, you know this one here, it's actually easy because you don't even have to do Riley Jiu-Jitsu on this one. This one's just here, it's just laid bare for you. This is like, you don't have to do right? There, so the algebra on this one is even easier than on the other ones we did so far, right? All right. Let's spin on this one here. It'll be Becky. What? Okay, that's good. That's the way it's supposed to work out, though. All right, Becky, what do we got here?
It's sine 43 equals x over 14.
Okay, and then to solve for x, what do you do? X is equal to? Okay, I don't want to have to flunk you back to Algebra 1, Becky. What do you have to do to solve for x?
You have to
Cross multiply, right? So 14 sine
Okay.
43 degrees.
Yeah.
So now punch that in your calculator, and you have your answer, right?
Okay, yeah. Okay, that's what I was confused about.
All right, good. Well, that was a good reason, because this is an example of how this name wheel thing is helpful. Yes?
Doesn't matter which way you put our variables.
Which way you do what?
Put our variables, like x over 14, put our 14 over x over
Yeah, here, because what it is, it really does matter, because the sine of 43 degrees is x over 14,
Okay.
but it's the reciprocal ratio. Cosecant 43 degrees is going to be equal to 14 over x,
Okay, I got
So
it.
right?
If we worked it out cosecant 43 degrees, would it get us back to the same answer just with the multiple step?
Yeah, it would. Now, it would, essentially. Essentially, if you solved it this one, it would be x equals 14 over cosecant 43 degrees,
I got
which you can write in your calculator. If you want to punch that in your calculator, you can write that as 14 over 1 over sine 43 degrees, right? Because that's reciprocal. So it ends up going the same place. Go ahead, Becky.
It's about 9.548. I just rounded up.
9.548,
548.
okay.
Yeah.
And then the last thing is you look at it, see if the answer makes sense in the context of what the angles look like. It looks pretty good,
I
doesn't
just
it?
rounded up on that one. Because it was like 8, 7.
Yeah, so you rounded to 3 decimal places is what you did. Yeah, that's good. 3 decimal places is a good standard for this class, particularly like on calculus, like the AP test. They have a 3-place rounding standard for that. Okay, that was good. All right, I'm going to call on somebody in a minute for this one here.
I see what you were supposed to do. You had to,
Yeah.
like, do it from
Okay,
14,
good.
not 14, sine over 14, or just,
Okay, now we're to this one, right? This one's going to be me. So that means I have to do it?
Yes.
All right. Okay, here we have, it looks to me, now correct me if I'm wrong, this is going to be our opposite, right? And this is going to be our hypotenuse. So I'm going to put this sine 35 degrees equals the opposite over hypotenuse. And then I'm going to use Riley's trademark method. I'm going to have y is going to be equal to 6 over sine 35 degrees. Does that make sense? And then my calculator, I think I have my calculator in radians if I'm not mistaken. Yeah, I need to have it in degrees. So I go to mode, change this to degrees. So I have, y equals 6 over sine 35. 6 divided by sine 35 degrees. So 10.461, does that look right? So I'll put approximately equal to
No, I rounded up the 6. It was 8.
10.461. And does the answer at last make sense? Yeah, pretty well. One thing you can look at, if you know the standard right, like a 30, 60, 90 is going to be 2, like if it's 30 degrees, this would be 12, but it's 35, so it's going to be a little less than 12. So that makes sense, okay? So I give myself extra credit for that. How's that?
Give yourself a sticker.
Yeah, I guess a sticker. That's what I'm going to do for 6th period class. I'm going to have a sticker, and then I'm going to explain. Maybe they'll make me do the same thing, though. Maybe I won't do that. Okay, 54. Robert. All right, Robert.
X equals 20.337.
20.337. What equation did you set up first on this one?
Cosine 66 degrees plus x over 50.
50
And then cross multiply
some
x
x.
equals cosine 66 degrees times 50.
Like that?
Yeah.
Okay. And see if that makes sense. Yeah, it does kind of, right? So that would be that. Okay, good job, good job. One thing we're going to learn to do pretty soon too is, given sides first, find the measures of the angles, but we'll do that later. Okay, I'm going to want to have that turned in, but I'm going to want to I'm going to give you something else we're going to start working on today. It's going to be this thing right here. Please be here, please be here. Please be here. Who's saying please not be here? Anybody? No. Okay. There you go. Yeah. You already have that one? I gave you another one, didn't I? Yeah, I gave you that one. Because I knew you did that. Set of papers. It is. There you go.
Yes. It was so fun. I'm sure it's not
There you go. This row here. Thank you. Okay, we're getting to the next section of the book, which is 4.3, and this here is called the quick review of that. And so there's some precedent for what these are already asking you to do. So it's really the review that's going to be most relevant for where we're headed next. That's what it amounts to. So in exercise 1-4, give the value of angle theta in degrees. Everybody knows how to do that? With the,
This is what I did not understand this.
you didn't understand that? Okay, but the main thing you have to remember is that pi pi radians is equivalent to 180 degrees. And so what you'll do here, if you have theta equals negative pi over 6, and it's going to be negative pi radians over 6, you go ahead and to convert units from radians to degrees, we're going to multiply by 180 degrees over pi radians. And radians over radians will cancel each other, pi radians will cancel each other. And so what you have is negative 180 over 6, so that's going to be negative 30 degrees. So that's going to be your angle in degrees.
You can have a negative and not a degrees.
Yeah, you can, and I'm going to show you where we're headed in the class here. Actually, standard, what happens is all these little posters, mini posters that Mr. Calvin left me a couple of years ago are examples of that you actually have 360 degrees with which to work in a rotation. Because we've been dealing so far with just acute angles, this little portion here, but we're going to examine other angles, and also you can go the other direction. So what happens is positive angles are represented by a counterclockwise rotation. So like pi over 6, like the unit circle trigonometry song, it's going to be pi over 6 right here, isn't it? That's the first one. It's equivalent to 30 degrees. But you can, and so standard rotation, positive rotation is in this direction. If you go this direction, that's going to be a negative rotation, so the clockwise rotation is assumed to be negative. So you can go down here to negative pi over 6. And if you go ahead and look at negative pi over 6 on our unit circle, it's the same thing as 11 pi over 6, isn't it? You see that? Our unit circle? You see where it says 11 pi over 6? So 11 pi over 6 and negative pi over 6 are what we call coterminal angles, is what it amounts to. And we'll talk about coterminality later on. So that's just a preliminary introduction to tomorrow, I hope. Okay, next I'm going to call on somebody for problem 2. It's going to be Jana. All right, Jana. All right, Jana, what'd you get for this one?
First, I have a question. Determine the answer. In the end, do you cross multiply and divide, or do you multiply the two numerators and divide it by 6?
You multiply the numerators and divide by 6. I think that's your question.
So it would be negative 153.
Okay. So she says negative 150 degrees. And I want to show you something on your unit circle. That's a correct answer. And you got it by multiplying by 180 over pi, right? Okay, that's right. I want to show you something on your unit circle. Okay, do you see where, you see right up here on your unit circle where it says 150 degrees, 5 pi over 6, you see that? Okay, so what happens is negative 5 pi over 6 is going to be the same angle, or the same magnitude of angle, but in the other direction. So what it is, instead of rotating up here like this to here, you're rotating this way to here, which is going to be, that's going to be negative 150 degrees, because you rotated the other direction. Instead of counterclockwise, you did clockwise, right? Okay, that's a good question. So the possibilities, we have other possibilities today. Okay, I want you to do this one. I'm gonna call on somebody in a minute for help with this one. And yeah, let's go ahead and talk about this. We'll talk about this. What if, okay, I'm facing you right now. Okay, I'm gonna do some camp. I'm facing you right now, so if I make a 360-degree turn, what is that gonna look like? It'll look just like this, right? But what if I make 2 rotations? What angle is that gonna be? 1, 2, how many degrees did I rotate then? 720. Very good. Okay, that's the integer, that's the arithmetic there. So yeah, I guess the point, one of the points of this exercise set is you can have angles bigger than 360 degrees. Does that make sense to you? Should, right? Okay. Now, let's go ahead and choose one of our, highly motivated, Elizabeth's highly motivated. She's going to be called on, maybe. Marina's going to be called on first, though. All right. What'd you get for this one? Okay. And then, so you got that by just multiplying by 180 over pi. Is that how you did it? Yeah, so that's going to be your correct answer. And I know that's the right answer because what? Because what did I do last night? Watch the video. I remembered this problem. Okay. Thank you, Karina. All right, we know who our next victim is going to be. Here we go.
Second time.
That's like the 15th time I've ever said it out loud before now. I thought I said the Jason. I remember.
All right, Elizabeth, what do we get for this one?
960 degrees.
960 degrees, okay. Which you got the same manner that Karina got and everything, right? Multiplied by 180 over pi. Okay? All right, really good. Okay, we have a next set we have here, which is using special triangles to evaluate. And what are the special triangles?
Like 30,
30,
60,
60, 90, and there's another
45, 45.
45, 40. Good job. Good. So these ones here, and we worked on, I think, didn't we work problems like this yesterday? Or was it the day before yesterday?
we kind of went over it a little yesterday.
Yesterday?
Elizabeth did it.
Oh, that's right. Elizabeth was, yeah. Okay. Let's go to, what we're going to do is we have a brand new wheel, don't we? Except, do you need me to work this out first?
Yes.
Okay. What it is, you have pi over 6, and I happen to know from the unit circle trigonometry song that that's going to be the same as tangent of 30 degrees, right? 0, 30, 45, 60. So that's our 30 degrees. And then so I can look at a 30-degree right triangle, special right triangle like this, and I say, okay, well, if you have 30 degrees here, this side's going to be x, and this side's going to be x squared root of 3. And so that's going to be equal to opposite over x squared root of 3 which is going to be equal to 1 over square root of 3, or if you rationalize it and multiply by square root of 3 over square root of 3, you get square root of 3 over 3. Okay, so that's 5 worked out. Does that make sense? So if you draw out the special right triangle, the brand of it, whichever it is, and you remember those things, you can cancel out and you'll get what it is. Okay?
I'll use my phone, I have a picture of it on there.
Yeah, that'd be great. Go ahead. Yeah. Okay, I'm going to erase this now. Now we are to number 6. Okay, yeah, we should be able to do this one here. And it's going to be open. We're going to get a new crop of people here. Okay, here we go. Number 6. It's going to be Elizabeth. All right, Elizabeth, you have this one?
I think so.
Okay.
So, pi over 4 is 45 degrees.
So it's going to be cotangent 45 degrees, what you're saying?
And then if you set up a right triangle, the opposite and the adjacent are both going to be x, so it's x over x, and that equals 1.
So you got x over x, and this is your adjacent, so here's your 45, and this side is your adjacent, and this side is your opposite, and you're going to have adjacent over opposite, which is this, which equals 1. Okay, is that right? Yeah, that's right. Okay? So Elizabeth, you feel like you climbed a mountain on that one?
Probably.
Elizabeth climbs the mountain. All right, good job. What's the hypotenuse? X squared root of 2. X squared root of 2. Yeah. So this, your hypotenuse, Elizabeth was asking, is going to be x squared root of 2. So that could be helpful, right? Yeah. Could be. Okay. Next, we have this one here, cosecant pi over 4. And that's going to be, well, Justin, he's not here right this second.
He always leaves.
Yeah. So Riley's going to get it instead. All right, Riley. All right, Riley.
I'm not 100% sure if I did it right, but
Okay.
I'll try.
Go ahead.
So cosecant of pi over 4 is 45 degrees.
So that's the same as cosecant of 45 degrees, what you're saying.
Yes.
Okay.
And it's a special triangle, the sides are x and the hypotenuse is x squared root of 2.
Okay, so you're talking about, here's your 45, and here's your x, here's your x squared root of 2 is what you're saying, is that right? Okay.
And since it's the reciprocal of sine, you do the hypotenuse over opposite.
Okay. So here's your opposite, here's your hypotenuse,
So you
Okay.
do x squared root of 2 over x.
x squared root of 2 over x, which is
The x's can cancel and it's just square root of 2.
square root of 2, okay? Everybody okay with that? All right. Sounds good? Yeah, because what it is, if you look at sine 45, it's square root of 2 over 2, right? So if you flip that upside down, what you have is you have 2 over square root of 2, which just simplifies square root of 2. So that is your correct answer, all right? So it's just, it's following the system. So there's kind of a system to it, isn't there?
So
Once you kind of figure it out.
I don't know if it's that, or if it's gonna be.
Okay, we have,
I thought, I mean, if it's low down in Hebrew, like separate, maybe give it.
we have number 8.
I just don't know if 2 actually is there.
Okay, number 8, we have, it's right here. That's gonna be me. I hope I get this right. Okay, this one here, it's gonna be equal to secant of 60 degrees. And so we have a 60-degree triangle like this, right?
Yes.
So I know this is 60 degrees here. And I know that this is going to be hypotenuse, which is going to be 2x over adjacent. Is that right? So x. So hypotenuse over adjacent is going to be 2x over x, which equals 2. So that's that one, okay? And then what we're left with is 9 and 10. And I kind of want to maybe just leave 9 and 10 for tomorrow, since we just didn't have, and those ones might take a little more time. So we'll just kind of leave it here today. So tomorrow we'll just finish up 9 and 10, and then it's like problems we've already done, so we'll just leave it there. How's that? Okay, good.